All right, so to do activity 4, you're going to need an equation that we used earlier in the year. We talked about springs, and we used this equation for the energy stored in the spring, called the elastic potential energy, is 1/2 k x squared. This k is the same thing. It's the spring constant, right? And then this x is the stretch distance, how much the spring has been stretched. So this is energy. So any question like this where it's asking about energy, you're using this equation to help solve it. So looking through this, these first three are all involving energy, so that's the equation you want. Number 4 uses energy, so again, using the same equation. And so in all these questions, in this one, 2, right, in one like this, you want to use the idea of conservation of energy. So remember, from chapter 5, energy can go from one form to the other. So we have kinetic energy, we have potential energy, gravity, we have potential energy, elastic, right? And so, like in this problem, it starts with potential energy elastic, and immediately as the spring is released, the ball has, the energy goes from elastic kinetic, but as it rises up, right, it's going to lose kinetic energy and gain potential energy. You need to figure out, to find its velocity, right, how much kinetic energy it has at this point. And from kinetic energy, remember, that's 1/2 mv squared. So from there, you can find the velocity. And so these are the appropriate equations to use. But using the same principles, right, this problem you recognize. This was from semester 1, person jumping on a trampoline. So just want to review and go back through those energy concepts. You can go back and look through your season 5 stuff if you want, or ask me, but this is how you work through these activities.